This is a lecture on how global winds form. For this lecture, you're going to need several different colored pencils or pens to make your notes a little bit more legible. So take a second and get some colored pencils. Okay, our first question, why does hot air rise? We all know hot air rises, that's why it's warm at the ceiling, but why does it rise? Hot air rises because hot air has molecules that are moving faster. Because they're moving faster, they're going to spread out, and if they're going to spread out, that's going to increase their density. Remember, density equals mass divided by volume. So if I keep the same mass but increase my volume, my density number is going to go down. Next question. What latitude are we going to find the hottest air? Correct answer is the equator, because the equator receives the most amount of direct radiation, therefore it's going to be the hottest. Next question. What happens to the airflow as it reaches the top of the atmospheric layer? Once it reaches the top, it's going to get pushed sideways, in this case north and south, because air that is rising up behind it is going to force it and push it out of the way. Okay, so with your first color, we're going to draw what the air is going to do in the troposphere, which is the bottom layer of the atmosphere. 0 degrees is our equator, so our air is going to rise up at our equator. Once it reaches the top, it's going to get pushed sideways, in this case north or south. Okay, our next question we have to think about is, why would air sink? It's the opposite of why it rises. It's going to sink because it's going to cool down. When it cools down, it's going to condense or move closer together, and that's going to cause the density to increase. So now that the air has been at the top of the atmosphere for a while, it's going to start to cool down. It'll condense. That'll cause it to sink at the 30-degree latitude, north and south. Once it hits the bottom of the atmosphere, which is the surface of the Earth, more air that is sinking behind it is going to push it sideways. So again, it's going to go north and south. Once they collide, that's going to cause it to rise up again. So now we have two complete convection cells. Now this process is going to continue. Since my air was sinking at our 30-degree latitudes, it is going to move towards the equator, but it's also going to move towards the poles, to the 60-degree latitude. Since it travels along the surface of the Earth from 30 degrees to 60 degrees, it's going to warm up in that time frame. That's going to cause it to rise up again. Once it gets to the top of the atmosphere, it's going to get pushed north and south again. At the 9-degree latitude, it's going to get cold and it's going to sink, and then again get pushed back to the 60-degree latitude. So these are the main convection cells that are happening in our atmosphere. The air is constantly rising, sinking, moving north, and moving south. This is a simplistic model of what's happening in our atmosphere. This is not going to be the true thing that happens in our atmosphere. This leads us to our next question. If air is moving west, why doesn't it actually move west? I had a little typo there, so I try to correct it with is. This goes back to a previous concept we were just looking at, the Coriolis force. If the Earth is spinning, everything on the surface of the Earth that is a liquid will also spin. Air in the northern hemisphere is going to be deflected to the right, if you remember. And in the southern hemisphere, everything's going to be deflected towards the left. Okay, so I'm going to draw some arrows in here in black. That represents the direction that the air wants to move at the surface of the Earth. But this isn't actually what happens, so don't draw it. So we're going to pay attention to our arrows right here along the surface of the Earth. And so this one's going to want to try to go due south. This one's going to try to want to go due north. This one will be due south. This one will be due north. Due north, and due south. Again, don't draw the arrows that I just did in black. We're going to use those as a starting point to draw the real direction of the winds. Now choose a different color. I'm going to go with green. And wind's always going to move at a 45-degree angle from the direction that it wants to move because of the Coriolis force. So if I'm going to look at this black arrow between 30 and 60 degree angle, between the 30 and 60 degree latitude, my wind is going to go that way because it's a 45-degree angle between this arrow and that arrow. That's a 45-degree angle. Okay, now I don't need this arrow anymore. I can erase that. And the green should be the direction that we actually observe on the surface of the Earth. Okay, these winds, or winds in general, always named from the direction that they come from. So this green arrow is coming from the west, so this wind is called the westerlies. Sometimes you might see the term prevailing westerlies. Okay, I chose 30 to 60 degree latitude first because the arrow is facing the correct orientation. But for the 60 to 90, my arrow is facing down, and the 0 to 30, my arrow is again also facing down. So if you want to see this properly, you're going to have to turn your paper upside down. Okay, so a 45-degree angle would be that direction. Oops, let me draw it again over here. Again, winds are named from the direction that they come from. So this arrow is coming from the east. We're also in the pole, so we're going to call it the polar easterlies. Okay, we'll see the same thing between the 0 and 30 degrees. Again, I'm just going to draw it over here where we have a little more room. And we again name the winds from the direction they are coming from. This is coming from the northeast. So we're going to call them the northeast trade winds. Now for the southern hemisphere, the winds are directed to the left. So in this case, again, 45 degrees from the west. I'm going to draw it again over here. And these winds are coming from the southeast. So we call them the southeast trade winds. Between 60 and 90 degrees, we'll see the same effect since the arrow is going towards the equator. This is coming from the east, and again, we're in the poles. So we call them the polar easterlies. And our last global wind pattern, 45 degrees to the left will be that direction. These winds are again coming from the west, so we call them the westerlies. Okay, next I want you to know where the United States is. Lidditz, Pennsylvania is about 40 degrees north of the equator, so we live in the westerlies. This means all of our global wind patterns, our storms, are typically coming from the west near California and heading towards the east.